We are looking at a $6 billion industry built around a product that the leading AI labs cannot definitively define. Thousands of pitch decks, a year of conferences, and no actual consensus. Look at Anthropic's recent autonomy study. They put it in plain text. There is still no agreed-upon definition of an agent. That is not an embarrassment for the labs. That is a concrete problem for builders. When you sit down to engineer a solution, semantic confusion translates directly into broken code. If the word agent includes everything from a basic retrieval chatbot to a complex, long-running tool-using system, the architectural decisions you make next get incredibly difficult. You end up deploying systems built for simple tasks into environments that require dynamic reasoning. We have to stop assuming we know what this word means. For architecture, the right definition isn't the broadest. It is the strictest, narrowest operational line we can draw to separate a standard script from a true autonomous loop. Because when a system fails in production, the question is whether it can recover from a mismatch between its intention and the outcome. Defining an agent rigorously is how we guarantee that recovery. 3 sources matter here. Russell and Norvig give us the classical baseline, a system that uses sensors to perceive its environment and actuators to act upon it. Wooldridge tightens that framework, requiring autonomy, reactivity, and proactiveness. Then Anthropic translates these theories into modern software practice, defining agents as LLMs autonomously using tools in a loop. All 3 definitions are academically accurate, but none provide a clear boundary line for developers today. They fail to differentiate a standard LLM hard-coded into a rigid flowchart from an LLM actively running a self-correcting loop. That specific gray area is exactly where builders get burned when shipping to production. Satisfying a textbook definition does not keep your application online. Surviving a mismatch between what your system intended to do and what actually happened does. Because classical definitions do not address dynamic error recovery, we need a new framework. We have to engineer a strict 5-part operational test. Contrast a basic thermostat that simply clicks on when the room gets cold against an advanced unit that actively checks the result of its last heating cycle before deciding what to do next. Both heat the house, only one is a loop. We can map that physical analogy directly onto the precise technical requirements for software architectures. This diagram maps the 5-part test. Step 1 is perception. The system must acquire state data from outside itself, reading an incoming message, parsing an API response, or taking in a retrieval result. Step 2 is reasoning. The system must decide its next action based strictly on its current state and objective, not because it is following a pre-written sequential script. Step 3 is action. The system must execute a function that meaningfully affects or probes its environment. Step 4 is reflection. After acting, the system must actively examine the resulting evidence and reassess its progress toward the overarching goal. Step 5 is state update. The insight gained from that reflection must directly alter what the system decides to do next. This creates a fully closed loop. The state of the world after an action is taken must become the new input for perception. Memory helps here, but having memory does not make a system agentic. Memory simply enlarges the loop. It does not define it. True agency is exclusively defined by a system's ability to use the world state post-action to dynamically compute its next move. Think of the difference between strictly following a recipe and watching a chef dynamically adjust the seasoning by tasting as they cook. Both produce dinner, but only one adapts to the reality of the ingredients. We see this exact distinction in the technical reality of modern automation platforms. This graphic illustrates the split. On the left, we have standard directed acyclic graphs, or DAGs, in tools like N8N or Zapier. These are paths authored entirely in advance by the human designer. Embedding an LLM node inside one of these fixed flowcharts does not create an agent. The LLM is merely executing a single step. It does not control the overall loop. Contrast that with the right side. Here, tools constantly report back to a central loop to determine the next step. The path is authored at runtime. This defines our exact architectural boundary, fixed orchestration versus runtime reevaluation. This is not a debate between code and no code. Advanced nodes within platforms like N8N can technically host recursive loops that evaluate and act. An agent workflow exists only when the developer defines the goal and the tools, but allows the loop itself to choose the exact path at runtime based on constraints. There are 4 highly popular system architectures that everyone calls agents, but they all fail this operational test. They share one fatal flaw. Each system produces a result, but completely fails to look at that result to choose its next move. Look at this grid. Prompt chains are not agents. They are predefined, linear workflows where one model call feeds into the next with zero dynamic pathing. Routers feel intelligent because an LLM picks the branch, but basic classification is not the same as reflection. They fail. Standard trigger action automations with a single LLM step fail. Their execution is ultimately dictated by the outer static graph. And retrieval augmented generation systems fail. Retrieval and tools are highly useful building blocks, but they are not loops. All 4 of these architectures are incredibly powerful in production. They process data, generate text, and route traffic efficiently, but they share the same architectural limitation. They treat the post-action world merely as a byproduct, not as necessary computational input. Because these systems lack runtime reevaluation, they mathematically cannot recover from execution errors. That permanently disqualifies them as agents. Compare a modern human editor revising a draft against an ancient piece of 1991 software pinging a mailbox. They look completely different, but these 2 systems actually share the exact same underlying architecture. This graphic shows Anthropic's evaluator-optimizer structure up top. It passes our 5-part test because it natively runs a generate, evaluate, and feedback loop. It reassesses the result. Below it is Wooldridge's old Unix daemon xbiff. It continuously monitors state changes, acts, and returns to observing. It perfectly fulfills classical autonomous action criteria. The essence of agency is strictly architectural. It is not aesthetic. Marketing labels mean nothing compared to whether a system treats its post-action state as an input for the next decision. Fuzzy spectrums are useful for analyzing overall capabilities or tracking product maturity. They are entirely useless for actual software design. When you are trying to decide what to build, a strict binary test is the only tool that works. Look at the architecture. Failing this test is not a moral failure or a sign of broken code. It simply means you built an automation, not an agent. An AI workflow crosses the threshold into an agent workflow only when an action is followed by reevaluation, not just the next pre-written step. Use this strict line for your internal design decisions. Ignore the semantic marketing fights. Passing the reflection test is the single architectural guarantee that your system can autonomously recover when its intentions do not match the outcome. Drop a comment with the system you are currently calling an agent. Tell me if it actually passes the 5-part test. In day 6, we cover the breakdowns. I will share exactly why I abandoned fixed automations in N8N and pivoted to building coded agents instead. The system that looks at its own output and asks, "What just happened?"